In this example, we're asked to identify some key features of the function f of x is equal to x squared minus 6, namely the domain in part A and the x and y intercepts in part B, and then come up with a sketch of a graph of the function. And this is pretty similar to what we've done. It's more of a review of what we did in section 1.2, so you might want to check out the video from that section for further information. And in class, we'll take a look at how we can use technology, namely the website Desmos, to help us plot and identify features on more complicated looking functions. But for this one, we can do this one by hand without the aid of any technology. So the domain of this function is going to be all of the x values that we could possibly plug into the function and evaluate and get us a defined output. And no matter what value I plug in for x, I can square any value of x and then subtract 6 from that value. So there's no bad values of x that will lead to something which is undefined. So the domain in A is all real numbers. So that would be everything from minus infinity to positive infinity. In part B, finding the intercepts, let's first find, say, the x-intercept. And to find the x-intercept, recall that these are going to be the values of x when we plug in to the formula, give us an output of y is equal to 0. So we set y equals 0 and solve for x. So here, setting y equal to 0, we get 0 is equal to x squared minus 6. This gives us x squared is equal to 6. And so undoing that operation gives me x is equal to plus or minus the square root of 6. And so remember, we get plus or minus here because squaring either positive square root of 6 or negative square root of 6, when I square those numbers, they both give me a 6. So we have more than one solution here. So this tells us what both of those solutions are. And therefore, writing out my intercepts as coordinates of points, we have one at negative the square root of 6, 0. And we have another at positive square root of 6, 0. Finding the y-intercept, this is going to be where the graph crosses the y-axis. In other words, this is going to be the value of y when x is equal to 0. So we set x equal to 0, and we evaluate the function to find the corresponding y value. So in this case, f of 0 gives us 0 squared minus 6, which is minus 6. So our y-intercept is located at 0, minus 6. So here's our y-intercept. These were our x-intercepts, and the domain was everything. So finally, in part C, we now can put this information together and come up with a graph of this function. So let's set up some axes, x and y. And so far we found that we have a y-intercept down here at 0, minus 6, and we have x-intercepts, say, over here and over here at minus square root of 6, 0, and square root of 6, 0. And we could figure out some other points in order to pick up on the pattern to sketch this graph. So for example, picking a few more values of x to figure out what the corresponding y value is, plugging minus 3 into the formula for f, I would get minus 3 squared minus 6, which would give me a positive 3. Plugging minus 1 in would give me 1 minus 6, which is minus 5. Plugging in 0, well, that would give me the y-intercept, which we've already found, at minus 6. Plugging 1 in would give me minus 5, and plugging 3 into the formula for f would give me a positive 3. So plotting those points, here we are at minus 1. The output was was minus 5, and plugging in minus 3 gave us an output of positive 3. Plugging in positive 3 gave us an output of positive 3. And so sketching a graph of this function, we get a parabola such as this one.